Welcome back from lunch. Looking forward for the next presentation. A while ago we talked at the coffee chat. I don't know, it was about 2 years ago, Mich and me, and now first time we see each other. He's famous for building Lego and being the ambassador for GitLab. Stage is yours. Thanks for being here.
Today I want to dive into efficient DevSecOps with CI/CD components. It's a pleasure being here. I'm Michael. I go as DNS Michi, which is DNS M-I-C-H-I. On the internet, I've been with GitLab for like 4 years and 3 months now, so time is flying fast. And I think we actually had a coffee chat in 2020 because Sid suggested that I have one with you. So we know each other a little long at least. So it's really, I'm really glad that I can be here in person. And I thought of like, how can I like start explaining what CI/CD components are and what are efficient DevSecOps workflows. And one of the things that resonate the most is like DevSecOps is all about speed. We do a lot of things with it. There's like testing, continuous integration, continuous delivery or deployment, vulnerability scanning, observability, infrastructure as code. Most recently, platform engineering. So a lot of things to consider. The problem is like, how fast are you able to kind of build a pipeline with multiple steps or document the usage or like modularize the pipelines or even like creating reusable modules for your team or even for the entire company. And then you kind of want to reorganize or refactor CI/CD pipelines without breaking everything, which I usually try, and then my pipelines are failing. So the kind of picture on the side could be pipeline running, or even like pipeline is broken and developers cannot continue their work. And so the idea was like, okay, how can we make it more easy to discover certain things in DevSecOps? We could use like Google search, we can use LLMs, or even like RAG. There might be a developer portal, or you just ask your peers, which takes a long time when onboarding or in a new team. Then how to use CI/CD or specific pipelines, like maybe there's documentation, maybe there's a wiki. Sometimes it's just read the code, self-explaining things. And then how to share that, like publish it somewhere. We need to have versions, because if we run latest all the time, we are breaking latest all the time. And we probably want to share it somewhere on a platform. And there are certainly other areas of improvements as well. And I thought of like a specific example that is very hard to kind of build out in a pipeline. So there's different ways you can kind of build a pipeline if you want to build it in a reusable way. You can use local templates. You can include templates provided by GitLab, for example, SAST or the different other scanning or Docker build variants. And there's also a way to use a project reference from a different project with a specific syntax. And this is all great, but when you want to modify certain things, it gets a little more complicated. For example, I have the stages, test, build, and deploy. And one of the templates I'm including has a stage called docs, because it generates some docs. And if you include that, the pipeline cannot be created, and it fails with a fancy error and says, well, the stage is not there. Please fix that. Dear developer, please do something about that. And one of the ideas could be like, hey, let's just add a stage. And then the upstream or the downstream project is really like for a lot of stages because included that. Then the included template renames the stage for some reason, breaks it again, need to rename everything. So it might not be the perfect solution for that. Another idea could be, hey, we've learned a trick in GitLab. We can just override the stage by just importing or redefining the job again. So the Rust docs job gets defined again and overrides the stage attribute. Could also work. But then you have a lot of clutter in your CI/CD configuration and need to remember why you did override this specific job. So you also probably don't want to have that. And one of the ideas that came about was so-called CI/CD components. And the idea behind a CI/CD component is like you want to have easy to assemble pipeline components. They should be consistent and provide you with repeatable workflows. You want to share them, you want to reuse them, but you also want to discover them. You can create an amazing CI/CD template or a component. If nobody finds that on the GitLab instance or on the platform, it's amazing to me, but not to everyone else. And it's really a great way also to like improve the collaboration and also increase efficiency in teams and projects. So the idea behind the component is it's a modularized job definition. You have a documented purpose, so there needs to be documentation for the component. You want specific input or output parameters, which are also documented. You want to be able to test the component, so not just testing in production and hoping it works, but rather have it in a dedicated environment. And use similar workflows to software development for release and publish workflow with versioning, and also, of course, allow others to contribute via merge requests, for example. So reusing GitLab as a platform to also maintain CI/CD components. The catalog on the other side is like the additional way of collecting all the CI/CD components. So you have an explorable index, a single source of truth. Everyone knows, here's the catalog, I can find it, can use it publicly or internal, and it enables reusability. And the great thing is also it has shared ownership. So either there are instance maintainers maintaining the components, GitLab Upstream maintains components, components are created by verified GitLab partners, and there are community-contributed components, which enables even more greater collaboration. And the adoption path can be in a way of, you have the templates, which exist today in a pipeline, and then consider adding or migrating to components, and use the catalog to make it more discoverable within the teams, and provide documentation. And also consider like copying that on the instance level and get to work. Now, how does this theory kind of look like, or how has it developed inside of GitLab, on the GitLab project? A CI/CD component is kind of comprised of a specific directory structure with a templates directory, with template definitions, and inside a specific template definition, you have metadata and inputs provided as a spec header or front matter. The idea here is to really use a GitLab project, the same release workflows. You can even use CI/CD to build and release a CI/CD component, and easily migrate existing templates or even like raw configuration and combine it into a CI/CD component. In order to kind of see how it looks like, I've thought about what could be a good example of showing what's possible with the CI/CD component. And a while ago, I was looking into learning Rust or writing Rust code, and I wanted to test it. So I created a top-down CI/CD configuration for building and testing Rust. Used the default keyword, defined the image, some caching things, some variables, and essentially calling cargo, which is the build framework provided in the Rust ecosystem. And I thought of like, okay, that's great, but how can I make this reusable in a specific sense and migrate that to a component? And I started reading the documentation. So there's extensive documentation available for CI/CD components. I created a GitLab project and then thought about a directory tree. So like templates is the component type. Currently, it's the only component type that is supported, but there will be more in the future. And the file name in there, like rust-basic.yaml, is the component template name. You need to keep that in mind. The readme.md documents what the component is about, how to use it, and the .gitlab-ci.yaml file is for testing the component and releasing the component and so on, which we will look into in a bit. Now, if I want to add the CI/CD jobs into the Rust component, the minimal viable change could be something along the lines of, I'm creating a spec. I don't define any inputs yet because this is a later step for refactoring, and I just copy over the build test and the build job and the test job using the stages, using the specific images, and then run that again. So it works in that iteration, but there's no optimization yet. when I have created the component for the first time, and the reason why I'm just like showing you how to consume it now, it's start with an easy 5-minute success moment, and then you can refactor it later on and optimize it and so on. And by consuming the CI/CD components, it's similar to including a template, but the important part is like the component keyword. Here, you define the URL where it's available from, so the component project path. It's a little longer because in developer advocacy we have a long subtree of different projects. And at the end, before the add, it's the component I want to include here. And after the add, we define the Git version tag. So it's using semantic versioning. You can also use like something latest or define the Git branch, like main. But the idea here is really you pin the version you want to include, and you're not breaking things that upstream might not have released in the main branch. The important thing to note here is there is no templates / in that path because that's automatically determined by the include path. I can also specify the inputs, which are currently empty, but this allows us to kind of dynamically use the component in the future. And this is actually the next slide. So the idea behind dynamic inputs is you can define a variable, you can define a default value, so that you can either force the user to kind of specify the value all the time, or define a default default value. You have a description, so it's possible to really like document the inputs in that way, and then use that with a specific $square brackets inputs notation within the CI/CD configuration. And in the example, here it defines the stage build and the stage test inputs, and then assigns the specific stages to the jobs, which makes it parameterizable from the output when you have, for example, not build and test the stages, but instead build and testing or something else. You can parameterize the component. You don't need to like fork it and maintain it on your own and things like that, but instead have it in a single source of truth. And even you can contribute upstream and work together on maintaining that component. From a validation perspective, like using that component, I can override it with an extreme test case and say I'm overriding the stage test to actually be the build stage. So I'm kind of modifying the default behavior. And the resulting pipeline on the right-hand side in the screenshot is in the build stage, we have 2 jobs, build latest and test latest. So the component works. And the great thing about this notation is I can copy paste it and then include a different component or the same component with different inputs if I need that, which could be useful if you, for example, build a component for different programming language versions, testing the Rust version, I don't know what is current one, 78 something, or different Golang versions and so on. Still reusing the same components. One other thought is you could even create dynamic job names, which wasn't possible for many years in GitLab now. And using inputs, you could, for example, say, I want to specify the Rust version, and default is latest. We're using like a tag from Docker Hub in that example. So I can instruct like using the image tag, but I can also override the job name. So for example, it will be like test-latest, but it's actually taking the input of the Rust version. And depending on what the user specifies, this gets then dynamically rendered or dynamically created in the GitLab CI/CD pipeline, which is also, if you need it, a nice way to always show which Rust version the job tested against. Because sometimes versions behave differently, break things, and if you don't know which Rust version in CI/CD is running and you need to pass all the job logs, in my own experience, you spend hours and weeks to figure out what's wrong, and it's screaming at my desktop. On the other side, this is actually like the validation of using multiple component includes and then specifying different Rust versions, getting to see like the different outputs in the stages with build and test. could expand that. The only problem is like it takes longer the more versions you add. But it's a great example for a different way of parallel matrix builds, for example. If you want to optimize the CI/CD components, there's certainly more things you can do, like split the single template into job-specific templates. So have in templates one build.yaml and one test.yaml file, and only a single scope job inside. Probably add more inputs to that. Think about caching and avoid global settings. So really make the settings local to the components and configure it that way. Before optimizing is probably also a good way to think about maintaining a CI/CD component, because it's not just created and then it's kind of running and nobody cares about it anymore, but you want to also like document it and also create tests for it. The README MD should be the entry point for documenting the best practices, like the purpose of the component, how to use it, maybe an inputs table. The GitLab CI/CD catalog also renders the inputs table automatically, so you need to decide whether you want to document it or just let GitLab generate that. And also the documentation should be an entry point, how to contribute, how does testing work, how does development of the component essentially work. This gets all rendered in the catalog as well. From a testing perspective, it's helpful to kind of see that inception in GitLab, sort of. So you can include the pipeline, the CI/CD component in an actual GitLab pipeline, and then test different input values and templates. It uses predefined CI/CD variables, so every time I make a commit in the same repository and change the component, it uses the CI commit char, which is the commit reference, and you always test the latest change with that specific component. It can be a little, head explodes way, but the idea is really to test it in the same GitLab project where you maintain the CI/CD component and not having to like create the components repository somewhere and the test repository somewhere and so on, but really make it sort of a mono repository in that regard. And the great thing is also you can just include source code in the same repository. And for the Rust example, I cloned the repository. I have my Rust environment installed locally in my dev environment. Cargo init initializes a new project. So it creates the source main.rs, which is shown in the example in Visual Studio Code. And the cargo.toml, which is the configuration for cargo in Rust. And then I'm good to go, probably. I can also like modify the source code and test specific extreme cases, or if the components needs to test, for example, for performance issues or regressions or something like that. You can even extend the source code and maintain that, again, in the same repository as the CI/CD component. So everything is contained, and those who want to contribute to the component, they can just follow the path in one repository and not just many of them. For visibility, I've talked a little bit about the CI/CD catalog. In order to publish a CI/CD component, there's a project setting in a GitLab project where you make this project a CI/CD catalog resource. So it's visible, it's not automatically visible. And the other thing you need to do is add a job to the CI/CD configuration, which then automatically publishes a release. And the only user action I need to do is create a git tag. So either I do it from the web frontend in create git tag, I think is the menu item, or I do it locally on my command line or in my IDE and create the tag and git push -- tags, and the release gets published automatically in the CI/CD catalog. So if the pipelines run through, of course. If not, I still need to fix something. From a visibility perspective, the CI/CD catalog is currently like available on gitlab.com, but also on self-managed instances. The idea here is you have /explore/catalog. You can search for the components. You can order it currently by release date, I think, but there is work underway to kind of improve that and make it more sortable. If you have ideas and say, well, we need some specific ordering, please contribute. Everything I show here is open source. The components or the components catalogs is a screenshot from Saturday. There have been plenty of contributions and people really starting to create components, not just GitLab, where someone, or Lee Ticket started the Ruby component. I think Raymond is involved as well. But yeah, so there are some examples here. For the Rust component I created a while ago, it's also visible if I search for it, and I can immediately consume it by clicking on it and inspecting the details. From a component's types perspective, the first iteration were templates, and there are some links on the slide, but at the end I have a QR code and you can immediately get access to the slides to follow the links. The first iteration are templates. The next iteration is something called steps, which I will show on the next slide. And we're also working on expanding the catalog resource types, like could it be some sort of built image or attaching more things into it, or a component could also be a Docker image or some sort of image. So this is open for discussion, and the product teams and engineering teams are actively working on that, but they're also dependent on feedback. So if you have a wish list for that, please share it. Steps is something I wanted to share, but I didn't try it yet, so I didn't have time. The idea is that you not only run a job with like scripts, script execution, but you can actually define steps. And this is a little bit inspired by GitHub Actions. And the idea also is to being able to run GitHub Actions into GitLab CI/CD steps at some point, which could be a way to make it easier to migrate or to integrate certain workflows and just use the best out of the ecosystem to some degree. And it should also be a way of hopefully to debug pipelines more easily on a local basis. I didn't have time on finishing the talk, but essentially you could just this is using uname to get the kernel information or the Linux system information, but it's probably a way of like making things more easier, more approachable in CI/CD. I think in 17.0 it's an experiment. You don't need to enable a feature flag, or do you need? The documentation should know. But you don't need to recompile GitLab yourself, so it's more like it's in all versions, and according to the docs, it's GitLab.com self-managed and dedicated, so it should be available to everyone. Just wanted to like share it here because it's one of the next steps, also for the CI/CD catalog, which still needs to be built. From an efficiency perspective, I do have some thoughts or some ideas which are relatively new, and GitLab 17.0 will be released on Thursday, I think. Yeah. So 17.0 also makes the CI/CD components, catalog, and inputs generally available. So the interface will be stable. And one of the important things is to not only support string as an input type, but also considering number, Boolean, and especially arrays, because sometimes you really need to specify an array as an input. And if it doesn't work, it's a bug or missing feature. And also to highlight are functions to manipulate values. So the idea is that you can like split a string or even like expand an environment variable from a different scope if that is useful to you. So the teams have been building specific functions into that. And I, as a programmer, I'm like, I have some ideas. I can add even like more functions to that. Let's see what the future brings and what users essentially want to add. But But yeah, it's making a CI/CD component even more dynamic from an input type perspective. From another perspective, dynamic inputs, what I've seen with many components in the catalog is you can use like for the string input the image for containers as an input. So some folks are using the Docker Hub images, others are using the GitLab registry or a different registry, and then being able to actually override the container image the job is executed in could be a great way to adopt as a best practice. I've also seen like we have hosted runners and runner tags as inputs. Could also be a way of saying we define a default array of runner tags for the component. Should be using like the medium tagged version or something like that. And I, as a consumer, can override that and say I want to use a different tag because this is a C++ or C project. It needs more compiling resources. And therefore, I need a large model or whatever is documented from the team that maintains the GitLab runners and the GitLab platform. What are the benefits of CI/CD components? Just a quick short overview. For programming languages, you can adopt the best practices like linting, building, testing, apply efficiency best practices. So I like to create efficient templates and pipelines, but how to share it with others on the team or in the company, or even like in the open source ecosystem, if you will. Think about dynamic workflows. It's like dynamic job names, something I always wanted even before joining GitLab. And I was like, it's not possible. Now you can do that. Version control, dependencies, and automated testing, and of course, visibility. So every time I create a component, I consider it a first iteration. I can publish it in the catalog, get feedback, or even use the same workflows as with a GitLab project, have my issue templates, my merge request templates, all the different triage workflows in order to maintain that. And I just wanted to highlight some contributed components or components in the catalog right now. So there's To Be Continuous, which is an open source group maintained by Orange. And they have CI/CD templates and now components, and they worked quite a lot of time to recreate all the different templates they have into CI/CD components. And one of them is Python with a description how to use it, with also like the CI/CD template notation, and it's available in the catalog and you can immediately start consuming it, which I think is a great way to do that. On the other side, GitLab has also been working with Google Cloud to bring CI/CD components into the catalog. One example here is to deploy to the Google Kubernetes engine. There's also a blog post linked about this. And the idea is, again, to make it easier, for example, to deploy to the cloud, virtual machines, Kubernetes clusters, whatever comes to mind, to really abstract that in a way that I don't need to think about how to define that parameter or even like think about IAM roles in AWS or whatever comes to mind. Things where I, as a developer, I'm like running away. Let's do the ops team. Oh, there's actually no ops team. I'm the ops team. I've done that in my previous job, so I can tell you certain horror stories in a different moment. But from like the maintain components, our teams are working on maintaining the Ruby component, which currently has, I think, lint and some other jobs or templates in the component to consume. We also have the OpenTofu component. OpenTofu is a fork of Terraform, and we're actively working on that. Timo is the maintainer, hopefully somewhere in the room. All questions to him? No, for components, you can also ask me anything. I cannot answer everything, but I can still ask our teams to help. So yeah, we're actively working on that. I also started working on Golang and Rust and a little more. So it's a community effort to really bring the components catalog to life. And certainly there's more use cases to that. So maybe you use Podman or Canico for building container images and not Docker and Docker. Could be a great idea or inspiration to create a CI/CD component. Different programming languages. Yesterday I learned the R language, which could be a fun or interesting way to kind of build into a CI/CD component. Certainly specific workflows from platform engineering, increasing the developer experience, identify some pain points and consider like solving that. Continuous releases, deployments, infrastructure as code and observability, security scanning, basically all the buzzwords. But in essence, you can automate and make it more efficient in many ways. Also like for embedded programming, automotive edge, machine learning even. I think our teams are also publishing certain machine learning workflows as components. So yeah, everyone can contribute. If you want to start today, create a component repository, convert CI/CD templates into components. So there is documentation or guidance how to do that. Release it, and there's also a development guideline which we maintain. We have some minutes. I'm not doing the workshop live, but I will shortly walk you through a real life example of how to migrate a Golang component from a CI/CD template into a CI/CD component. I did that in January, and for this talk I refreshed it a little bit, so you get the latest knowledge of that. So the idea is to analyze the existing CI/CD template, which is provided by GitLab, split the jobs into specific component templates, optimize with dynamic inputs, and then test the source code, and then release the source code. And the idea here is that you can follow the exact same steps either for the Golang template or for the template you're using, and then practice that and put it even in production if you want to. So for example, for the Golang component, for the Golang CI/CD template, there's the image declaration, which is global. We should avoid that and move that into the job definition for a CI/CD component. Then we can see, I'm not sure if you can see that, on the slide now, but the format job actually runs multiple Go commands. So it runs go fmt, go fat, and then go test. Test doesn't make much sense in the format job. So we probably want to split that and fix a long-standing problem. And from a naming perspective, it's also unclear. The compile job runs go build. Maybe it makes sense to call the job name just build and match that on what the Go command is actually doing. So we want to rename the job. Then I can define optimization strategies. So the stage attribute is hard-coded. We want to configure that. The image attribute is hard-coded, especially using the latest tag, which is something I totally want to avoid with components. The compile job uses a hard-coded binary output path. So it's using my binaries. Probably I want to use something else and make it configurable. So I can create a template directory structure. It's like creating a file for format, build, and test in the templates directory. Initialize the Git repository and add like a README, git ignore, GitLab CI YAML, and also a license to ensure everything is in the project here. And a little bit too much text on the slide. But I want to create like the build template for the CI/CD component. So the job name should be dynamic. So the user can specify another job name, the stage, the Go image, and the binary directory. So I can add a dynamic job name configuration to it, assign all the different inputs, and have really like a self-contained testable CI/CD component. I can repeat the same steps for the format component. In the Go component, the format type or template, and the same for the test. And when I want to test it, I can again repeat the steps that are also in the documentation. So I used GitLab CI/CD for testing the CI/CD component, specify different input values. I also found a way to use parallel metrics for that. So the Ruby component maintainers use that. And there's also a new variable available in GitLab 17, I think, which is CI server FQDN. So it automatically detects your instance URL, so you don't need to change between gitlab.com and your instance URL. Everything is automatically detected, and you don't need to change that when migrating a component from the SaaS platform to the local instance, for example. When you want to add some Go source code, I played around a little bit with AI in GitLab Duo to generate the source code to really have like a real world example testing the calculation of pi and some other things, like to have a real world environment to test and not just hello world. Again, verifying everything, document it, publish it, and release it. And yeah, that's roughly now done in 3 minutes, what you probably can do in probably 1 hour just to practice and get going fast, hopefully. So just to recap, getting more efficient. We have reusable, self-containing building blocks for CI/CD. It's visible and discoverable. We can share best practices. It's formalized and testable with inputs or input parameters. Can create and consume them. And anything from maintaining them and collaborating on them should be relatively straightforward. Here the slides, I think they will also be available on the website. But if you want to immediately get access to the slides, you can do it now. Otherwise, thanks for the attention. And you want to go with the questions or with? Okay, questions first.
Just comparing to GitHub Actions, I'm not like a huge fan of how sometimes you include an action that's supposed to run a tool, but actually it's 100 lines of a Docker file and 500 lines of a shell wrapper. But sometimes it's useful to have that as part of the component itself, rather than using external images. Are there like some plans to have that so that if you have a component, you actually have its own Docker file, and it just kind of like let's say a standard approach to having internal images that are shipped with a component?
Yeah, I don't know the exact issue or epic, but there has been discussions around it. And if you cannot find the issue, please create a new one and tag me in there, and I can help loop everyone in or like share it with Rocher, and we can figure something out in that regard. Because I think templates are just the first step, which is already there, and everything else we kind of add on top to that as a component type.
Thanks for the talk. It's really exciting for me because it sounds like it will solve a few issues we have in our monorepo. So even without sharing or anything, just being able to be more flexible to reuse CI code that you've already written should enable us to eliminate some repeated code. Are monorepos something that's being considered as a use case for this feature, or is that basically by pure chance?
So what you can... It depends on what the approach for the CI/CD component could be, but we've also seen in the catalog there are projects that combine different job templates already for different purposes, and then you selectively kind of include it if you need it, but you can also create the all-in-one component that builds the entire monorepository if you want to. Maybe from a maintainer perspective, it could make sense to kind of define the monorepository contains Golang for the backend and the front end is a mix of Ruby or Vue.js, like create specific components that test the code functionality, for instance, and then and then combine it into the inclusion in the downstream project.
But our use case is more like that we have multiple very similar projects within the same repository that we would like to built the same way. And until now, we basically have to copy-paste the job definitions and also give each job its own name. With this, it should be more easily to be reused.
Yeah, I think how to best start that. Maybe figure out one of the jobs that gets copied the most often, and then figure out what is the difference in that one project and the other one. Maybe it's just a flag or something you want to have as a parameter to the component, and then experiment. When I set the backend is enabled to Boolean true, a specific job gets executed in the component, and if not, it just doesn't run. So you can instrument how the component jobs are actually executed from inputs.
But this monorepo or reusing the same jobs within the same repo wasn't really a design goal for this, as I understand now.
I'm not sure if I follow the question. Maybe it's
fine, but thank you.
Maybe you create a pipeline project, and there you manage all of the templates, and all of the other projects use this one. Yes, my suggestion maybe because I guess the complexity in the pipeline configuration file come from two areas. One area is addressed in your presentation is the configuration part. The second part might come from the script itself, because there we have to implement a lot of business logic that is really unique to our product line. And maybe just back to his question, I guess I'm also using CSC every day. Maybe just to create a pipeline project, because here we are talking about actually the so-called pipeline engineering, which is a little different from the engineering process we build our product. So, and my suggestion there is to create a pipeline project that can be used to manage all of the templates or components, whatever we call it, to maximize the reusability of these components. Yeah, and in your mono case, my question here is I'm really happy to hear about more parameter types are going to be supported. So we have a challenge is in our product line, we are building the software, the embedded software for the drive systems at Siemens. Mm-hmm. We have around 6 product variants, and we have a very complex upstream pipeline, and this upstream pipeline will trigger different downstream pipelines, and the ultimate goal of this upstream pipeline is to generate the software for each product variant. And then the challenge for the user workflow is when it comes to releasing the software is we have to request the user to fill in so many parameters on the upstream pipeline. Because, for example, if you are releasing the software for the Pixel, releasing the Android system for Pixel and for Samsung, depending on Pixel or Samsung, the product variant you select, you have to fill in all the other dependent parameters. And therefore, the question here is, can you guys introduce kind of dynamic visibility control of the parameters, as well as the more advanced controls to visualize these parameters?
I think to some degree you can solve the problem by using component inputs with like defining the list, defining the default values, and only when the user needs to override a specific set, like it's a different product type, you might use it or define it internally and the user doesn't see anything about the if-then-else conditions. From a visibility perspective, I don't know the current plans for like how to visualize a component. I personally would love to have a drag and drop editor or something like that, or like a pipeline workflow sort of thing. And then you can kind of say, I don't want to use this input, or maybe this is dynamic, or like a simulation mode. Yeah, but I would love to learn like more about this. So if I can invite you to also like engage with issues and in a feature request, or just come to us after the talk, I can engage more. Raymond wants to steal.
I'm just going to steal the show for a second before Roger comes and takes the fun out of it. Anyone who was at my talk last year, we briefly spoke about at GitLab we have a core team, which is a team that we have dedicated from community members who have been recognized as consistent contributors to the GitLab open source project over a significant amount of time. And these core team members are there to help us keep our values, keep our open source ethos, and keep building the open source community. And I just wanted to take this opportunity to welcome Roger Meyer to the GitLab core team.
Yeah, happy to join the core team, and yeah, thanks guys. Thanks,
Thank you,
Michi. And yeah, we continue doing the contributions and so on, but now we have a little break for 50 minutes.